All right, in this question, we've been given a design size for a shaft and a hole, and the clearance, the maximum clearance and the minimum clearance. And so the question is asking to determine the shaft and the hole dimensions given a design size of 1.5 inches and a maximum clearance of 0.007 inches and a minimum clearance of 0.003 inches. And then it says to use unilateral tolerances. Okay, so this is going to be a clearance fit between a shaft and a hole. And so the hole is going to be slightly bigger than the shaft for a clearance to occur. So the design size is 1.5 inches, the max clearance is 0.007 inches, and the minimum clearance is 0.003 inches. So I like to write that down in, some area here. I'll just call it given. Okay, so I'll denote design size as D, and that's going to be 1.500 inches. And so I'm going to drop the units from now on because I know that I'm working in imperial units. Okay, and then the maximum clearance is equal to 0.007 inches, and the minimum clearance is 0.003 inches. Now I also have to decide whether or not I want to use the basic shaft system or the basic hole system, because that's going to impact the formulas that I use. I'm going to assume basic shaft system. And so what that means is that the shaft is going to be the basic size or the design size, and the allowance is going to be applied to the hole. Okay. All right. So speaking of allowance, what is allowance? So the allowance, I'll denote as A, is going to equal to the minimum clearance. Okay. And then that's really useful because I use it to determine the hole diameter. Okay, so the diameter of the hole is going to be equal to the design size of the hole plus the allowance. Okay, and then I have to apply tolerances to this. I'm also going to use the maximum material condition, which would mean that the hole will get larger in size for its tolerances, but not smaller. So put 0, 0, 0. So it doesn't get any smaller than the design size. But we do not know the tolerance of the hole at this point. That comes from a formula, which I'll get to in a moment. Okay, and so then the diameter of the shaft is equal to just the design size because I'm using the basic shaft system. And the shaft, I'm going to use maximum material condition. And so that's not going to get any larger than the design size, but it is going to get smaller by some amount. So let's figure out, what the hole tolerance and the shaft tolerances are, how we calculate that. Okay, so the whole tolerance is equal to C max minus C min, okay, over 2. So basically, I'm taking half of the clearance and applying it to the tolerance of the hole, and half of the clearance and applying it to the shaft. Okay, so it's going to be negative though, the maximum clearance minus the minimum clearance over 2. Okay, and then I'll just put brackets around this. Make sure that this negative applies to the whole formula. Okay, so after this, once we have this all laid out, we're in pretty good shape to start solving some of these things. Okay. Maybe I'll switch to magenta here to work on the solution. So before I forget, I'm just going to formally determine what the allowance is. All right, so the allowance we said was the minimum clearance, and that is equal to 3 thou. Okay, and then we can use that to determine the hole diameter. So the hole diameter, and that's going to be the design size plus the allowance, and this is going to equal to 1.500 plus 0.003, and that's now 1.503. So we've done pretty well here so far. We've figured out the hole diameter, but we do not know the tolerances yet. So let's calculate the hole tolerance. So TH is equal to the maximum clearance minus the maximum or the minimum clearance, and over 2. So let's figure out what this is. So 7 thou minus 3 thou over 2. So this is 7 minus 3 is 4, and 4 divided by 2 is equal to negative 2 thou, or sorry, just 2 thou. Okay, so now I can finally write the hole diameter with the tolerance. So that's 1.503 plus 0.002 minus 0.000. Okay, so I may as well put a nice box around that. That is probably worth some marks there. Okay, and now I'm going to figure out the shaft diameter and shaft tolerance. So let's write this one down. So the shaft tolerance is just equal to D, which is equal to 1.500, and then the tolerance, the shaft, is equal to negative bracket the maximum clearance minus the minimum clearance over 2. Okay, and so if we just look at this formula up here for the hole tolerance, it's the same formula except there's a negative sign in front of it. So we'll just say that's negative 0.002 or 2 thou. Okay, and so once I have this figured out, I can write down the shaft diameter with the tolerance. Okay, and I'll put another box around that. Okay, so that is the shaft tolerance. Now, if we wanted to check to make sure that these diameters and tolerances were correct, we could, manipulate these and do some math to figure out if we in fact get a maximum clearance of 0.007 and a minimum clearance of 0.003. So let's try and do that. Okay, so in our maximum material condition, this is sometimes denoted as MMC. Okay, and so at the maximum material condition, the smallest hole will occur. So we can kind of write it like this. So the minimum clearance is going to equal the smallest hole diameter minus the largest shaft diameter. And so if we look up here, the smallest hole that we've calculated is 1.503. And the largest shaft size is 1.5. So that is in fact, typo there, 3 thou. So excellent. Okay, now in our minimum material condition, and I'm a bit at a loss of what this is called because if you abbreviate it, it would also be MMC. So just double check that. But anyway, the maximum clearance would equal the largest shaft or hole size minus the smallest shaft size. So that is going to equal 1.503. Maybe I'll just write it down here. 1.503 plus 0.002 minus 1.500 minus 0.002, and that's going to equal 1.505 minus 1.498. Okay, so I could pull out my calculator, but I think I'm going to calculate it manually. But I really don't like working side to side like that, so I'm going to just change it so that the larger diameter is over top. So 1.505 minus 1.498. Okay, so 5 minus 8, I can't really do that. I'm going to have to borrow from my next digits over. I can't borrow anything from a 0, so I'm going to have to borrow from this 5 here. So I'll just cross out that 5 and put a 4 over top and put a 1 right here. So now I got a 10 that I can borrow from. So I'll cross that out and make that a 9. I'm just going to borrow 1 from it. So now this is 15 minus 8, which is 7. And then 9 minus 9 is 0. And 4 minus 4 is 0. And 1 minus 1 is 0. So I do, in fact, get a maximum of 7 thou. So I've double checked to make sure that the clearances were applied correctly, or the tolerances were applied correctly by checking out the clearances once again. So this is how you apply tolerances to the diameter of the hole and the shaft, and it's also how you determine the hole diameter when you're using the basic shaft system.